Hey everybody. So to answer the question of who wins the 100 meter race, what I'm going to do is I'm going to use a spreadsheet to figure out that answer. So first over here you can see I have the time in seconds. So I just listed out some seconds so that I can represent the turtle's distance, rabbit's distance, and gator's distance in meters from the start line after each second. So we know that the turtle gets a 60-meter head start. So at time equals 0, he's going to be at 60 meters already. He travels at 3 meters per second, and so that means every second he will go an additional 3 meters. So I can just add 3 meters every second, highlight this, and drag down since Excel should know what the pattern I'm using. And you can see somewhere between 13 and 14 seconds, the turtle will have finished the race. Now to go for rabbit, he starts at the starting line, so at time equals 0, he's going to be at 0 meters. And so after 1 second, he's traveling at 1 meter per second. So that means after 1 second, he will have traveled only 1 meter. After the next second, he's now going to be traveling at 2 meters per second. This means that after the next second, he will have traveled a total of 2 meters. And that's in addition to how far he's already gone. So there should be a total of 3 meters. That's how far he is from the starting line. Now we can think about after the 3rd second, he will now be traveling at 3 meters per second, which means after that second, he will travel 3 meters. Now I notice that that just happens to be this number, so I'm just going to cell reference that so that I can use the drag feature and not have to do any more calculations. So that's how far he's going to go after the next second, and that's in addition to what he's already gone. And this will allow me to drag down. Now I can see again somewhere between 13 and 14 seconds the rabbit will have finished the race. Now we can go over to the gator. He gets a delayed start, so he actually doesn't start the race until 5 seconds, which means after 6 seconds he will now finally actually be at 1.5 meters. And this is because he's traveling at 1 meter per second, so after that second he will have traveled 1.5 meters. Now his speed is increasing by a factor of 1.5, so his speed is now actually 1.5 squared meters per second. And so since we're only going a second, that means he's gone an additional 1.5 squared meters. And that's in addition to what he's already gone, so we can add them together. Now, if I start thinking about the relationship between the time and the power, the difference is just 5, and that makes sense because he gets a 5-second delay. So for instance, after 8 seconds, the power will be 3, or 8 minus 5. So I can use that relationship, 1.5 raised to the power of 8 minus 5, so that I can just cell reference. And I know that's in addition to what he's previously gone. And creating this will just allow me to drag down so I don't have to do all those calculations again. And again, somewhere between 13 and 14 seconds, the gator will have finished the race. Now my goal here is to graph it. So what I'm going to do is I'm going to create a new column with 100 as all the y values, just so that I can graph that line y equals 100 and make the visualization a little bit better. So I'm going to highlight these, and I'm going to insert a graph. I'm going to use a line graph instead of a scatter plot just so that I can see that nice curve and see where they intersect. It's hard to see a little bit, so I'm just going to make it a little bit bigger. And so what I'm looking for is I'm looking for which of these lines is going to hit, or which of these curves is going to hit this yellow line first. So if I'm looking between this blue, this orange, and this gray curve, it looks like the blue curve actually hits y equals 100 first. And that blue curve corresponds to the turtle, which means that since the turtle reaches 100 meters first, the turtle will have won the race.